Zach LY the Science Guy.
Basically what this experiment consisted of was taking two different types of flies, red-eyed fruit flies and white-eyed fruit flies, and breeding them together so that we could more thoroughly grasp the concept of fruit fly genetics. Oh, hey there. I didn't see you there. I didn't realize you were behind me. Anyway, Gregor Mendel did an experiment similar to this, and it only consisted of pea pod plants instead of fruit flies. And he used the concept of true breeding to breed the pea pods together to study the genetics of the pea pods. We're just going to do that same thing, but with fruit flies.
Okay. With a little bit of gold in the page. Yup.
Alright, so first of all, we had to verify the pea generation flies. We took white-eyed males and red-eyed females, and we placed them together in a certain test tube. We had to discover which fly was which sex and which trait the eye color was. So what we did was we put it under a microscope and put them to sleep with this fly nap. So the traits we identified were eye color and gender. We looked through a microscope to see what color of eyes they had. For example, this right here is a red-eyed fly, and he's a male, I think. So, yeah, that's what we have. Oh, hey, I didn't see you there. First of all, we needed to get the pea generation into the proper test tube. So we had to verify which sex was which and the trait of their eye color. So we took one of these handy-dandy microscopes, and we placed them under it and looked to see whether it had a male or a female reproductive organ. This picture helped us identify whether the fruit fly was a male or a female. If it had a bottom side similar to this, it was a female. If it had it similar to this, it was a male. Males typically had darker abdomens, and the females had lighter. So in order to fully grasp this idea of fruit fly genetics, we needed to have various generations. So we started with the pea generation, was the first generation we had. They breeded and they made the F1 generation, which was the parents of the F2 generation, which we studied and found out our results. When the type of inheritance is dominant and recessive, when the pair is heterozygous, the dominant trait will always show up. For example, if red is dominant and the pair is red-white, red's dominant, so it will be red eyes. And when white is dominant, if the pair of traits is heterozygous, white will show up. Okay. In incomplete dominance, if the pair of traits is heterozygous, it will show a pink trait because red and white are by themselves homozygous, but when they mix together, they create pink. In codominance, when both traits show up on a heterozygous level, they both show up. Instead of it being a mixture of both, like in complete dominance, they both show up. In the sex-linked type of inheritance, traits are carried on the X chromosome, and since the male doesn't have two X chromosomes like the female, whatever the male inherits is going to be the trait that he has. For females, they have two X's, so they can carry traits on both of them, so there's a higher chance of it being heterozygous. In this case, the female offspring is going to receive whatever the mother has, and in the male offspring will also receive what the mother has because the male only has one trait to give. Obviously, fruit flies cannot end up with red and white eyes at the same time, so we know that that is not the answer. That can't be in complete dominance because there are no pink eyes, it's just red and white, so that can be crossed off as well. This is a pie graph of the F1 data that we received from the fruit flies. We had 52% red males, 37% red females, 3% white males, and 7% white females. So as we try to decide whether the type of inheritance for fruit flies is sex-linked or dominant recessive, we're going to look to our F2 generation data to receive our answer. As you can see, The same amount of red males as there is red females as there is white males. So we know that since over here there's obviously not supposed to be that many white flies in general, we can cross out dominant and recessive, which leaves us with our answer being sex-linked. The type of inheritance for fruit flies is sex-linked. I'm gonna have to keep a straight face. It's gonna be tough. All right. Oh, hey there. I didn't. Oh, hey. I didn't see you there. What am I trying to say? True breeding is. What is true breeding? True breeding is a concept. True breeding is a concept taken by Gregor Mendel.
Like an intelligent voice.
True breeding is a concept
Mr. Herbert.
discovered by Gregor Mendel. Okay, so let's just try this again. Okay, stop recording it. Go. Oh, hello there. Hit my nose. Okay, one more time. Oh, hello there. I didn't see you there. True breeding is a concept. I already said that, didn't I? So let's start over again, but okay. This is what was that noise? Alright. So
I'm still high, I'm sky high, and I dare anybody to try and cut my wing. Sugar, how you get so fly? Sugar, 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 sugar, how you get so fly?
You know what's left?
Hey, hey, teach me how to do it, hey. They be like smooth.